Page IN 33, lesson IN 6 is on cross sections. So what we're going to be doing is looking at cutting three-dimensional figures and looking at the cross section of that, basically looking at where we cut it, what two-dimensional figure would show up at that place where the figure is cut. So if we look at the next page, example 1, Rachel and Francesca went to a restaurant that serves rectangular bread rolls. Each girl sliced her roll in a different way. What do the cross sections look like? Okay, so here's our definition for a cross section. So it's a two-dimensional shape that is exposed when a slice is made through a three-dimensional object. So if we have a three-dimensional object, we slice it, we cut it somehow, we're going to see a two-dimensional shape, and that's going to be the cross section. So we can look at this. So Rachel cut from top to bottom, and so if you look, that vertical slice you can imagine would be like this, and so that would be a 3-inch by 2-inch rectangle. Francesca cut horizontally, and so again, if we can imagine that also would be a rectangle, which is 4 inches by 3 inches. Now obviously, when we're doing this, you know, a loaf of bread is probably not exactly a rectangular prism, so these are probably not going to just maybe perfectly be rectangles, but it'll be pretty close. So if we look at the try it, Zachary made a vertical slice that was parallel to the left and right faces of a bread roll. What shape is the cross section and what are its dimensions? So here's the picture, and we've got to figure out what the shape is and what the dimensions are going to be. So as the picture over here is suggesting, maybe, it is going to be a rectangular cross section again. And then if you think of that cross section slicing vertically, this would be a 4-inch by 2-inch or 2-inch by 4-inch rectangle. So to fill in the blanks over here, we could say first blank would be rectangle, and then this would be 4 inches by 2 inches. One thing just to mention when you look at these problems, they're showing for the slice, they're showing like these green sections showing how it's being sliced, and you might look at that and you might notice that this is overlapping, that we've got this extra stuff outside of it. Just remember this is just, they're extending it beyond the object just so we can see easily where it's being sliced, how it's being sliced, but then ultimately it's, you know, after we slice it, if we open this up, what would be the dimensions of where it was cut at. Example 2, Kenya made a sandcastle in the shape of a right rectangular pyramid with a height of 9/10 of feet, 9/10 of a foot, I guess we could say. So part A, if Kenya sliced the castle horizontally, parallel to the base, what would the cross section look like? Well, what's going to happen here if we do horizontal slices, it actually is going to depend on where we slice it at, because this pyramid is getting smaller as we go towards the top. So you can see towards the bottom here, that's going to be pretty close to the size of the base, but as we get up further and further, these are going to get smaller and smaller. They would be, if you'll notice, our base is a rectangle, so they would be rectangles, but they just progressively would get smaller as we move upward. And then part B talks about if they slice it vertically through the top vertex, perpendicular to the base, intersecting the 0.75 foot edges, what would the cross section look like? So they were very specific about how this was being done. So this is what that slice would look like, okay? Going through the top of the pyramid, down through the 0.75 foot side. And if you think about that, if you cut that open and look at it, that's going to end up being a triangle, and it actually is going to have a base that's 6/10 of a foot. Okay, if you imagine it was cut through this side, so when we open it up, it's actually going to have this side as the base. Okay, and this is going to be an isosceles triangle. So for this triangle, we have a definite point that we cut this at. We have a definite dimensions on this. Again, we have a base of 6/10 of a foot. We have a height of 9/10 of a foot. But for this other one, we know they're going to be rectangles, but we don't know what the exact dimensions are going to be unless they tell us those. Look at example 3. Jonathan used a mold to make a cylinder out of clay. How can he slice the cylinder to make a rectangular cross section? So if you think about this, we have this cylinder. So if he does a horizontal slice, that is just going to be the same size and shape as the base. In other words, this is going to be a circle if we slice horizontally. If we slice vertically, then we would get a rectangle. And it's just going to depend where we slice this. Vertical slices should give us rectangles. If we go through the center, then it's going to be as tall as the cylinder, and it's going to be as wide as the diameter. If we don't cut in the center, then it's going to be a little bit smaller. The height's going to be the same, but it's not going to be quite as wide as we get further to the edge of the cylinder. So if we look at the try it, they want us to draw a cross section that's created when a vertical plane intersects the top vertex and the shorter edge of the base of the pyramid. So we got to make sure we're getting exactly what they want here. So it's a vertical cut basically. It's intersecting the top vertex and the shorter edge of the base. Okay, so they've got it drawn for us. They wouldn't have had to have done that though. That was nice of them, I guess, but we got to make sure we know how to do this also. So we know it's through the top of the pyramid. It's also through the shorter side. So that's why they put it this way, because 3 inches is the shorter side. So it's going through the 3-inch side. And then we have to think about what shape that's making and what the dimensions are of that shape. So the height is going to be 4 inches, and then if you think about it, the base is actually going to be 7 inches. Okay, we cut going through the 3-inch side, so the 7-inch side is going to be what we're going to have. So it's going to be basically a triangle with the base of 7 inches and the height of 4 inches. So if we look at the key concepts, just kind of recapping things, talking about our cross section. So think about what direction you're cutting and what the cross section would look like. So there possibly is a square. They didn't give us dimensions on that one, but it's for sure a rectangle anyway. For that one, we've got a triangle cross section, and then this last one would have a circular cross section. If we look at the do you know how number 4, The divider in a desk drawer is a cross section that is parallel to the front of the drawer. What is its shape and what are its dimensions? Okay, so we're talking about the divider. It's parallel to the front of the drawer. So we're talking about this thing here, basically. Okay, so we want to know the shape and the dimensions of that. So we can see this divider would be a rectangle. It technically has thickness to it, so it's technically a three-dimensional figure, but we're going to kind of ignore that factor. And then the dimensions of that rectangle, if you can think about going across here, so that's 8 centimeters going across, and then going the other direction, top to bottom, is 5 centimeters. So it's a rectangle. It's 5 centimeters by 8 centimeters, or probably realistically a little bit smaller than that if it's fitting inside of the drawer. Does that make sense? We're probably like, maybe routing out little parts in the side that this can slide down into those slots. And so it's, it could be 8 centimeters by 5 centimeters, but only if we have like this whole drawer is like cut and then the other back half of the drawer is being attached to the back of it. Otherwise it'd be a little bit smaller than that. Number 5, draw the cross section that is formed when the pyramid is sliced vertically through the vertex and its right face perpendicular to its base. So through the right face, we're going to assume that this over here would be the right face that we're slicing through. So we're slicing through that, we're slicing through the vertex, and it's a vertical slice. So we're starting from the top and going down through that. And it says to draw this cross section. So we're not just describing it, we're actually drawing it this time. So if you think about this, we are going to have a triangle. And then on the triangle, we'd like to put what the base and the height are. The base is going to be this 9 millimeters. And then the height is going to be 10 millimeters. We're slicing right down through the middle there. If we look at number 6, what's the shape of the vertical cross section of the cone and what are its dimensions? So if we do the cross section here, you can maybe visualize that actually would be a triangle. And it's going to have a height of 6 inches. And the base, if you'll notice, the 2.5 is like the radius. So all the way across here would be double that, so that would be 5 inches. We could go a step further if we wanted to, and we could actually think about if we've got this 2.5. Imagine splitting that triangle we just did into half. Okay, if we take half of that, we've got 6 inches for the height, 2.5 on the other part, and that would be a right angle. So we could actually find what the other sides of this triangle are in this case. So if we were interested in doing that, we could actually use Pythagorean theorem and we could find this out. We're trying to find the hypotenuse. 2.5 squared is 6.25. 6 squared is 36. Okay, and this is probably going beyond what they're actually asking us to do here, but just to mention this. And then it's c squared. So we would need to take the square root. Technically we do plus or minus there, even though we know it can't be a negative distance. Anyway, this comes out to be 6.5. So what that tells us then, if we go back to our picture, it tells us that this would be 6.5 inches and this would be 6.5 inches, because both of those would be the same as each other, both of those smaller triangles. And so then we have all those dimensions, and then technically, more specifically than just saying it's a triangle, we could say it's an isosceles triangle, because we have two sides of the triangle are the same length as each other. We're going to look at a problem here. It's not in your books. So which of the following may describe a cross-section formed by a horizontal plane above the base that intersects the faces of the pyramid shown? So they're telling us it's a rectangle. The question is what the dimensions of the rectangle are. Okay, so if you think about this, our base is 20 feet by 8 feet. We're doing a horizontal slice. So slicing horizontally. If you can imagine that. This is maybe not as good of drawing of how the book can show this to you, but slicing horizontally there. And thinking about the dimensions of that rectangle. So one thing, if we think about this, if we're slicing this above the base, our base is 20 feet by 8 feet, so the rectangle cannot be that big. The rectangle is going to have to be smaller dimensions than that. And then one thing we haven't really talked about here, this is why I wanted to mention this problem, is what should happen is when you do slices further up from that base, the rectangles should be similar to the base. They should be similar, so in other words, the side lengths should be proportional. So one way of looking at this, we've got 20 feet and 8 feet. We could look at how those compare to each other. So 20 over 8 reduces to 5 over 2. So what we want is, we want our side lengths to be in that same proportion, a 5:2 ratio from the length to the width. Okay, length to width reduces to 5 over 2. So if we look at these options, the first option we have 15 by 6. So this, we can actually reduce both of these by 3, and that would be 5 over 2. So that appears to be our answer. Probably would be good just to check the others just to make sure. 12 and 4 reduces to 3 to 1. 16 by 4 reduces to 4 to 1. So that is going to be the case. So like I said, just kind of another interesting fact when we do these cross sections is that we are going to get similar figures to what our base is if we're cutting parallel to the base anyway. So this gives you an idea of how to work with cross sections. Have a good day.